Assalamu alaikum. This video is about symmetry of graphs of equations. What is symmetry? There are three types of symmetry. Symmetry with respect to x-axis, symmetry with respect to y-axis, and symmetry with respect to origin. Symmetry with respect to axis. So this graph is symmetric about x-axis. You notice that there's a point x comma y on this graph, and there's a corresponding point x comma negative y. So if we have for any point x comma y, there must be a point on the graph x comma negative y. Then the graph is symmetric about x-axis. So this graph is symmetric with respect to y-axis. So you notice that there's a point x comma y on the graph. There is a corresponding point on the graph negative x comma y on the graph. So when you have this situation, you can say the graph is symmetrical about y-axis. Or graph has is symmetric with respect to y-axis. Symmetry with respect to origin. Notice that this graph is symmetric about the origin. So you can notice that there is a point x comma y in the graph. Then there is a corresponding point negative x comma negative y on the graph. How we test? We algebraically, if you have a given equation for symmetry. So here are algebraic tests for symmetry. So the graph of an equation in x and y is symmetric with respect to the x-axis when you replace y with minus y and simplify the equation, and the equation does not change, it stays the same. Then the graph is symmetric. The graph of equation is symmetric with respect to x. The graph of equation is symmetric with respect to y-axis when you replace x with minus x in the equation and the equation does not change. The graph is symmetric with respect to origin when we replace x with negative x and y with negative y and equation does not change. So here is an example. So we're going to test for symmetry with respect to x-axis first. So the equation is y squared equals to 5 minus y. So according to test, we're going to replace y with minus y. So where y is, we put minus y. Since the original y has a square, so the negative y will also have a square, equals to 5 minus x. When you square a negative y, it becomes positive y squared. So now the result is y squared equals to 5 minus x. And now this is same as the original equation. So we will say, yes, this equation is symmetric with respect to the x-axis. Now we're going to test for symmetry with respect to y-axis, same equation. So here's the equation y squared equals to 5 minus x. Now to check for symmetry with respect to x, we will replace x with negative x. So we copied on y squared equals to 5 and replace the x with negative x. Now we simplify. So you can see negative times negative x become positive x. So we have y squared equal to 5 plus x. Now look at this equation and the given equation, they are different because this is a negative x, here we have plus x now. So they are both different. So we'll say the graph of this equation is not symmetric with respect to y-axis. So let's test this same equation for symmetry with respect to origin. So here's the equation y squared equals 5 minus x. We can replace x with minus x and y with negative y. So this becomes square of negative y equals to 5 minus and x becomes negative x. Square of negative y is positive y squared. We negative 5 and negative x become plus x, become 5 plus x. So this is the same, this equation is not the same as the original equation because here we have 5 minus x and this is 5 plus x. So we'll say it is not symmetric with respect to origin. So this equation has a symmetry only with respect to x-axis. Example 2a, testing for symmetry with respect to x-axis. Let's test y equal to x squared minus 5 for symmetry with respect to x-axis. So let's write the division equation, y equal to x squared minus 5. Now replace y with minus 5. So y becomes negative y and you have equals to x squared minus 5. Simplify, mean divide by negative 1. So negative y over negative 1, x squared over negative 1 minus 5 over negative 1. Now we simplify. Negative y over negative 1 becomes positive y. X squared divided by negative 1 becomes negative x squared. Minus 5 divided by negative 1 become plus 5. So now look at this equation and this divisional equation and you can see this is different. So we say no, not symmetric with respect to x-axis. Example 2b, testing for symmetry with respect to y-axis. So we're going to test y equals to x squared minus 5 for symmetry with respect to y-axis. So let's write the original equation, y equal to x squared minus 5. Now we're going to replace x with negative x. So the equation becomes y equals to square root of negative x minus 5. Now we simplify, well, square root of negative x is x squared. So we have y equal to x squared minus 5. Now this is same as the original equation, y equal to x squared minus 5. So the answer is yes. And this equation is symmetric with respect to y-axis. Example 2c, testing for symmetry with respect to origin. Let's test y equal to x squared minus 5 for symmetry with respect to origin. Write the original equation, y equal to x squared minus 5. Now we replace x with negative x and y with negative y in the equation. So y becomes negative y equals to x squared becomes square of negative x minus 5. Now we simplify. So when the square of negative x is square x squared. So we have x squared and minus 5 equal to x squared minus 5. Now we look at this equation and look at the original equation. This y is negative and this y is positive and this y is negative. Everything else is the same. So therefore they are not the same. So we say no, it's not symmetric with respect to origin. So equation, the example 3a, testing for symmetry with respect to x-axis. So we're going to test y equal to x cubed minus 5 for symmetry with respect to x-axis. So write down the original equation, y is equal to x cubed minus 5, replace 5 with minus y. So y becomes negative y, x cubed stays minus 5. Now we can divide by negative 1. So negative y over negative 1 becomes positive y. X cubed over negative 1 becomes negative x cubed minus 5 over negative 1 becomes plus 5. So this equation is not the same as the original equation because here you have a positive x cubed and here you have a negative x cubed. So we'll say no, the graph of this is not symmetric with respect to x-axis. Example 3b, we're going to test for symmetry with respect to y-axis. So here's the equation, y equals to x cubed minus 5. So write down the equation, y is equal to x cubed minus 5 and now replace x with negative x. So y says y, x cubed becomes negative x cubed minus 5. And the cube of negative x is negative x cubed. So like this one, y equal to negative x cubed minus 5. Now compare this equation with the original and you can see this equation is different than this equation. Because here we have a positive x cubed and here we have a negative x cubed. And everything is same. So we'll say no, not symmetric with respect to y-axis. Example 3c, testing for symmetry with respect to origin. So we're going Let's test y equals to x cubed minus 5 for symmetry with respect to origin. So let's write division equation y equal to x cubed minus 5. Replace x with minus x, y with negative y. So y becomes negative y and x cubed becomes negative x cubed minus 5. Now simplify. Cube of negative x is negative x cubed and minus 5 is minus 5, minus 5. So now you can see that this equation we can divide by negative 1. So negative y over negative 1 minus x cubed over negative 1 minus 5 over negative 1. So minus 5 over negative 1 is positive y, minus x cubed over negative 1 is positive x cubed, minus 5 over negative 1 is plus 5. Now look at this equation and compare with the original equation. So you have y same, x cubed is same, but we have plus 5 and minus 5. So these two equations are not the same. So equation changed. So we'll say no, not symmetric with respect to origin. Example 4a. Testing for symmetry with respect to x-axis. So we're going to test x squared minus y squared equal to 9 for symmetry with respect to x-axis. So let's write on the original equation x squared minus y squared equals to 9. Replace y with negative. So remember, to check this symmetry with respect to x-axis, we're going to replace y with negative y. So now we have x squared minus y changed to negative y, so becomes square of negative y equals to 9. Now bring down x squared minus, and the square of negative y is positive y squared equals to 9. Now this equation is exactly same as the original equation, x squared minus y squared equal to 9. So the answer is yes, symmetric with respect to x-axis. Example 4b, testing for symmetry with respect to y-axis. Let's test x squared minus y squared equal to 9 for symmetry with respect to y-axis. Write the original equation, x squared minus y squared equals to 9. Now we replace x with negative x. To test for symmetry about y-axis, you have to replace x with minus x. Now x squared becomes square of negative x minus y squared equal to 9. When you square negative x, it becomes positive x squared. Minus y squared equal to 9. Now this equation is the same as the original equation, so the equation did not change. So we'll say yes, the graph of this is symmetric with respect to y-axis. Example 4c, testing for symmetry with respect to origin. So let's test x squared minus y squared equal to 9 for symmetry with respect to origin. Let's write the original equation, x squared minus y squared equals to 9. Replace x with negative x and y with negative y. So x squared becomes square of negative x, y squared becomes square of negative y, and equals to 9. Now we simplify. Square of minus x is positive x squared. Square of negative y is y squared. You don't multiply negative negative. First you square. So then you multiply. So it'll be negative y squared equals to 9. So you can see this same equation is same as the original equation. So the equation did not change. So we'll say yes, the graph of this is symmetric with respect to origin.